Behind the world's most recognizable skylines, structural engineering turns height into something stable, efficient, and meaningful. This episode begins LERA's Global Engineering Practice Series with 5 landmark supertall projects. A supertall tower is never only a tall object. It must resolve wind, gravity, seismic response, vertical transportation, usable floor plates, construction sequence, and public identity at once. TBU facts give us height, floors, and structural material. The deeper question is how those facts become a buildable system. At 4 World Trade Center in New York, the engineering challenge was tied to both performance and memory. TBU lists the tower at about 298 meters, with 72 floors and a composite structural system. The office plates needed clear views and generous spans, while the site demanded security and dignity after the World Trade Center redevelopment. LERA worked with the owner and design architect to support an 80-foot main span and perimeter cantilevers, creating open workplace floors without letting the structure dominate the quiet architectural presence. Shanghai World Financial Center rises 492 meters with 101 floors, a national landmark in Pudong's skyline. LERA's role was not simply to make the tower stand taller, but to improve the structural logic behind an ambitious design. The alternative system supported a taller building on the existing foundations while reducing steel and concrete quantities. Supertall engineering is judged not only by strength, but by efficiency, robustness, and construction speed. Here, offices, trading floors, hotel, museum and retail become one coherent high-rise system. In Seoul, Lotte World Tower reaches 555 meters with 123 floors, nearly twice the height of the next tallest building in South Korea when completed. Its program is dense: office, retail, hotel, office-tel, parking, museum and observation spaces. The structural order uses 8 concrete mega-columns, core walls, outriggers, and belt trusses to share gravity and lateral forces. Different functions want different floor layouts, but the lateral system has to remain continuous from podium to crown. LERA's engineering makes that vertical complexity legible. Merdeka 118 in Kuala Lumpur rises about 679 meters with 118 floors, becoming one of the world's tallest buildings and a centerpiece of a historically significant site. The crystalline form gives the tower its identity, but also raises the engineering stakes. The structure has to control wind response, support a very tall mixed-use program and coordinate with the massive podium below. Reinforced concrete mega-columns and core walls, paired with outrigger trusses, organize forces through the tower. LERA's design makes the symbolic profile, hotel, offices, observation levels, and public podium one buildable system. Bank of China Tower in Hong Kong shows how structural logic can become urban identity. TBU lists the tower at about 367 meters with 72 floors and a composite structure. Its external bracing and geometric order are not hidden behind the architecture, they are the architecture's public expression. Inspired by a cube rising from the ground and divided diagonally, the tower translates load paths into a clear visual language. For LERA, this is a landmark example of engineering and architecture working as one discipline. The structure supports the tower, shapes its silhouette and gives Hong Kong a recognizable civic marker. Across New York, Shanghai, Seoul, Kuala Lumpur, and Hong Kong, these projects show a consistent idea. Supertall engineering is not the pursuit of height by itself. It is the practice of connecting architectural intent, structural efficiency, construction control, and long-term value. LERA's work turns complex towers into systems that can be understood, built, and used. Beyond structure is the way cities and buildings truly stand. This is the LERA Global Engineering Practice Series. The next episode continues.